Good evening. We will start today's session. Um, Mohammad, if you want to give your presentation, you can start giving it.
Yeah, sure. Just a second.
Yes.
Am I audible and visible also?
Yes, you can start.
So, good evening, everyone. My name is Mohammad Saim. I'm from the Data Engineers Group. The topic for today's presentation for me is exploratory data analysis on credit card fraud detection. So, let's get into it. So first, let's see what the contents we'll be doing and assessing. So first, we'll see what is actually exploratory data analysis, what is the problem statement that was given to us. Then we'll try to understand the problem through story. Then we will do some basic data structure exploration along with some feature engineering and correlation processes. And then we'll talk about the modeling process that we have used, and then we will observe the results and finally the conclusion. So first step, what is actually exploratory data analysis? So in simpler terms, exploratory data analysis or EDA in short is a very important step in machine learning to visualize and visualize our data set that we are given, both in a graphical way and both in a statistical way. So by visualizing and statistically assessing our data set, we can conclude that what type of data set is given to us and what type of observations that we are getting and what can we achieve it from it. And mainly it involves like mainly plotting some graphs and making some tabular structures that can help us in understanding that how this data can help us in future when we are modeling our data. So next is what the problem statement is. So we were given a credit card fraud detection for EDA. So what is actually credit card fraud detection? So as the technology has advanced over for a long time, we have seen that there has been an exponential growth in credit card usage. And with that usage, we have also seen that there have been many instances of fraud, as you may have seen in the news or you may have read somewhere. So where does EDA comes into it? So by employing EDA, we can actually assess that, okay, that these are some of the patterns that the fraudsters or the hackers these are using to exploit the problems in the credit card transactions. And by those assessing those problems, we can see that, okay, that we can solve but these problems in these particular area. So let's understand through an example. So, for example, you are working in a like a finance company or a banking company, and there is an instance that many of the you are reported that a fraudster or like a group of fraudsters have actually stole data of credit cards or like there have been irregularities in the money transactions. So now what you can do is you can hire a data analyst team. A bank may have its own data analyst team, or they can hire someone, and what the data analysts would do, they will perform EDA on it that we just discussed, the introduction of it. So by employing EDA, they will see that like what type of on which type of data set that we are given these they are performing such fraud activities. They can assess the locations, they can assess the timings that when the frauds are happening, and on those basis they can like report to the banking officials so that they can act upon it. So first, like we will see what the data was given to us. So in our data, like we had, we will see in the future when we'll go over the Kaggle data set. But in like short, we were given the time and we were given 28 columns, which were actually in like named V1 to V28. We do not know what those actual column names were, because in the data set is given that due to privacy reasons, they cannot be able to like disclose the information of the users because it was a real-time data set. That why it was controlled using PCA. So PC is actually like converting those features into some reduced dimensions, so that many people can work upon it without hindering the privacy of the users. Second is the data cleaning process. So in data cleaning process, we will check that if there are any duplicate values or null values, so that we can remove it before our feature engineering processes. And thirdly, we'll visualize it using some charts and graphs to understand the data. So in firstly, we can see like in the transaction time distribution, like this is the data, like a visualization of the 2 day transaction of the credit cards. So you can see like you can observe that mainly like whenever where it's achieving the peak, that means like during the daytime, maybe it is many of the transactions are happening, and at the night time, like there are less transactions. So this is just a 2 day data set just to visualize that okay, that is the count of the transactions that are happening. This is for the real data set, non-fraudulent data set. This is the class distribution. So you can see like 0 denotes that these are non-fraudulent. That means there was no irregularities, and 99.8% does not have any fault in their transactions. However, just a small percentage, that is 0.2%, oversaw fraudulent activities. So you can see that it's a highly imbalanced data set. The problem with highly imbalanced data set is that whenever you are modeling your any type of machine learning model, what it will do is it may have a very biased approach towards the non-fraudulent data and may not be able to correctly predict the fraudulent data set. That's why it's important that before modeling our feature, we perform some feature analysis and exploratory data analysis, so that we can conclude that okay, we should normalize these particular features so that our model trains better compared to on an imbalanced data set. So this another visualization on the distribution of fraud transaction versus non-fraud transactions. So like fraud transactions, you can see that these are more regular and seen on any timely basis. That means that the fraudulent activities can occur like at any time, and there is no actual pattern to it. However, like in non-fraudulent transactions, that are the real transactions happening, you can see that at particular time, as seen before, like the transaction are maximized, maybe like on an opening week, when like on previous days when the banks were closed or something like that. So the on that days the activities are more as compared to any other time. So after we have like pre-processed our data set, we come to feature engineering processes. So feature engineering basically is that on the present features that we are provided, we transform that raw data into some of the features, into some features or modified features that we can use to better our model that we are going to train on it. And feature engineering can be modifying the present feature, or it can be adding a new feature, or it can also be like on a particular feature we can derive some another feature based upon some current feature. For example, like in our case, we employed two new features, which was the transaction R and the amount. So the transaction R is like instead of like seconds that the data set that we were seeing, like in case of this graph, if you see that this is in seconds, so like we can convert this into an hour time base, and we can normalize the amount column also, that so that there is much more normalization on the data set. This is a correlation heat map. So the correlation heat map will tell us about the correlation of the features among them. So for example, if you see like in the class data set, the darker the color is, that means that there is a positive correlation. And the lighter the color is, there is a negative correlation. So if you observe the class column, you can see that in Like in V6 or V8, there's a very negative correlation as compared to like V2 and V4, where we see a positive correlation. So coming to our main part, when we have actually like pre-processed and featured our data set, what we'll do is we perform some feature selection process also. That means that we will pick up the 10 most important features from the data set using the RFE function, which is provided in one of the libraries from the class variable. Once we have the 10 most important features, we'll apply a model. So the model that we have chosen is a logistic regression model. So logistic regression model, in short, what it does is it works upon a threshold value. For example, it will give us an output between 0 and 1. So if the threshold value, for example, is set to 0.5 and the value that we are having is greater than 0.5, that it will give us an output of true or 1. And if it's less than that, it will give an output of false or 0. And for evaluation basis, we have the normal 80-20 data split. And for the metrics, we have used some evaluation metrics like precision recall and F1 score, just like we'll see in the data set. So let me go over towards the data set just a second. So first, like before going on to the the Kaggle dataset, was first we can see what the dataset was provided to us. So here they have mentioned that it contains like over 492 frauds over these many transactions. And for like the numerical inputs, it was a result of PCA transformation because for confidentiality issues, they were not able to provide all the original features. That's why like they are providing us with the like most like correlated features only. So now go towards the EDA. So first we our code starts with like importing the libraries. Mainly the like the RFE function used to select the 10 most important feature, the logistic regression model, and some libraries for evaluation, that is the classification report. You can see the data set here, like it has the time column and it has features from V1 up to V28, and at last it also has the amount of transactions. After that, we have done data like pre-processing, that we have checked for any null values and we have dropped any duplicates if there are any. And after that, this is the graph that I show that the transaction time distribution one, that in some there is a much more frequency as compared to some other time. And if you see this is the class imbalance, which I also put in the presentation, which tells us about these are mostly the non-fraudulent transactions. There is a very small or is why you can see this tells us about the fraud transactions. And this is the same in just a pie chart format. And if we come towards data visualization part, you can see that over the time, what amount the people have used for like transaction. So mainly you can see like below 5,000 people have done their transaction, with some exceptions going up over till more than 25,000. But these are just some of the cases. And then we can coming to statistics. So we calculate a total of three statistics: mean, median, and standard deviation. The reason we are calculating this, that it will be important for us in the feature engineering process. So like, for example, a standard deviation, we calculate a standard deviation of 250. That means like it has like a very wide range of transactions, as we saw in the above graph, like it can go from below 5,000 to more than 25,000. And like if you see that like the median value, it tells us that the majority of the transactions may be relatively small, that we saw that were below 5,000. So in feature engineering processes, what we are doing is we are just normalizing our data. We just are taking the time in terms of R, and we're also normalizing our amount. Once we have normalized that, this is the correlation that we saw in the presentation. One more thing that we do is outlier detection, for that in case there is any like data point that is not relevant to us, we can remove that. So you can see that there were no outliers in this, because for like any Z score which was less than 3, we removed it, but the outliers remained like the data frame remained the same. And mainly this is the final part where we perform feature selection. So in the feature selection, again, we selected the 10 most important parts, features. And after that, we performed the logistic regression model upon it for 1,000 iterations. And then we take a split for an 80-20. So the test size is 0.2. That means 20% test size, 80% training size. And these were our results. As you can see, like the weighted precision was around 0.89, recall was 0.75, and accuracy, it was able to predict of 1. So coming back to our presentation. So in the result and analysis, you can see that the accuracy which we were able to see was 1. That means only means that we were only able to predict the classes correctly. That means this does not mean that our model is perfect. This means that all the classes were predicted perfectly. The precision is 0.8, which means that the amount of the transaction, it was able to predict the 80% of transaction as fraudulent. And a recall has a positive class of 0.58. That means if we see the overall weighted score, it was actually able to identify 82% of them. So coming to the conclusion, we were given a data set for credit card fraud detection, and we had performed EDA on it. So using various feature engineering process and data visualization process, we were able to observe the what type of transactions are happening, at what time they were happening, and what is the class imbalance, that how many transactions have happened which were fraudulent. And on that basis, we were able to collect some information upon it and uh, train a model upon it to see that how much accurately we can predict it and detect that, okay, this is a fraud detection task. So these are the differences. First was, of course, the Kaggle data set that was provided to us. Second was an article on a EDA of the it's a Medium article. Third and fourth were for particular this project for like the correlation analysis and logistic regression for some theoretical part. So this is all. Thank you, and questions are welcome, of course.
Okay, Mohammed. So the presentation was nice. You had the flow, you knew what you were talking about. At the same time, there were two things missing from, so not missing actually. One is the thing that you can improve on. If you could have given me a short story stating the relevance of the project in real life. So right now there is I don't know if you can make a story about EDA because it is a theoretical
I
part on
actually
this.
included one story, for example, if you see understanding through an example, when I said that, for
Okay,
example,
yes.
if you
Okay. Then that will count as a story. Okay, that is fine. Yeah. Another is the information that you've put in the slides. Okay. In some of the slides, I felt that like when you were talking about the models and all those things. So at that time, you can keep the model names, you can take the information out instead of keeping it or keeping all the information here. Because when you talk about feature selection model evaluation, you can tell them to me by your own instead of keeping the information here. Okay, it will look more clean instead of categorizing these three into different parts of the slide. Other than that, I don't think I find any problem. Yes, if there are any problems, then I'll mail you on your review itself. Okay,
sure.
thank you, Mohammed. You can stop the presentation. Uh, Let me see who has raised their hands. Kushagra and Shivanshu, if you want to give your presentations, please do raise your hands. Shivanshu, you can start.
Is my video visible, sir?
Yes,
Video
the
and
video is
audio.
visible.
Okay, I'm sharing my screen. Um, Is my screen visible, sir?
Yes, the screen is also visible. You can start.
Good evening, sir. And my topic is predictive modeling. So first of all, I will tell about my task. The task involves building a predictive model to forecast the math score of a student using the variables like gender, race, ethnicity, parental level of education, lunch, and test preparation courses. The model will utilize supervised learning algorithms like decision trees, logistic reasoning, and random forest. So first the question comes here is, what is predictive analysis, predictive modeling? Now, what is predictive modeling is the process of using historical data and statistical techniques to make predictions about the future outcomes or events. It involves analyzing patterns and relationships in the data to create a model that can forecast the future behavior. Predictive model is essential in various fields such as finance, healthcare, marketing, and more. It helps organizations make informed decisions, anticipate customer behavior, optimize resource allocations, and improve business performance by leveraging data-driven insights. Predictive modeling empowers business to gain competitive edge and make accurate prediction to drive in growth. As you can see in this image also, first we will get the data and we will prepare the data. Then we'll train our model and test data and then refine the data by from our results. And this is all predictive modeling is. Now I will tell something about data set. The data set which I used is student performance, and it contains information about students and their performance in various areas. The columns in the data set include gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, and reading score. So before diving into the modeling, it's crucial to explore the dataset and gain a better understanding of its structure. In this slide, I showcase the first few rows of dataset and providing glimpse of various variables and their values. So in the previous set, I have shown some of the rows of the dataset at gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, and reading score. And in these slides, I have given glimpse of numerical variables, statistics of numerical variables, which include means, standard deviations, and quartiles, and offering insights into distribution and range of the variables. These here we can show data types of various rows. Now this next question comes here is categorical variables. There are many categorical variables in this data set. Now, category values provide valuable information in predicting the math score. In this slide, I visualize explore the distribution of categorical variables using count plots. Count plot displays the frequency of each category, allowing us to observe the performance and patterns within the variables. We especially examine variables such as gender, race, ethnicity, parental level of education, lunch, and test preparation course. Now the question comes here, why we have not used bar plot? Why we have used only count plot? So the difference between count plot and bar plot is count plot and bar plot are two types of plots in Seaborn, a library for data visualization in Python. Count plot is categorical plot that displays the count of observations for each category. And bar plot is numerical plot that displays the mean value of numerical variable of each category. So here we can see the categorical variables, count plot for gender and count plot for race and ethnicity. Now continuing from previous slide, I explore the categorical variables in the dataset, and I present the count plots for parental level of education and test preparation course variables. These count plots provide insights into distribution of students based on parents' education, lunch preparation, course completion. Now, the numerical variable. To understand distribution of math score, I focus on numerical variable math score. In this slide, I present a histogram that represents the distribution of math score among the student. A histogram shows the frequency of score within these specific intervals, means providing insights into overall pattern and shape of distribution. Here we can see the shape of distribution is like a bell shaped, is like a normal curve. Now, encoding categorical variable. To prepare categorical variables for modeling, we have to perform encoding. In this slide, I have used label encoding to convert categorical variable into numerical representation. This encoding technique assigns a unique numerical value to each category within the variables. So here again, gender is only male or female. So 0 represent male and 1 is female. Race ethnicity here is 0, 1, 2. So they are more than three values for race and ethnicity. So the values for here is 0 and 1 and 2. For parental level of education is also 0, 1, 2, 3, and 4. So The value assigned to the category value depend on how many values are there for each categories. So next comes here is correlation matrix. To explore relationship between the numerical variables, I create a correlation matrix. A correlation matrix quantifies the strength and direction of linear relationship between variables. In this slide, I display the correlation matrix using heat map, which utilizes color intensity to represent the correlation values. Heat map make it easier to identify patterns and dependencies between variables. So here, we have to predict math score in this task. So we can see that reading score and math score correlation is 0.82. This means that reading score is directly proportional to math score. Then there are very much possibility that the student is scoring good score in reading are also scoring good in math score, and vice versa too. So here I have in average math score by reading score. So here we can see that the students who are scoring good reading score are also scoring good in maths, and this is the correlation matrix which it has been solved. So next step come here is data pre-processing. To ensure an unbiased evaluation of our predictive model, we split data set into training and testing sets. The training set is used to train the model, while testing set evaluates its performance on unseen data. Additionally, I mentioned data normalization techniques such as standard scalar or min-max scalar can be applied if necessary. Data normalization ensures that variables are on similar scales and preventing certain features from dominating the model training process due to larger magnitude. So here is feature selection. Feature selection helps to identify the most relevant features for predicting the math score. In this slide, I have utilized this select k best, a feature selection technique along with F regression scoring function. Select k best selects top k features based on the relationship with the target variable. So here k is 5. So I am selecting the top 5 features. We then obtain the selected features which are variables deemed most information for our predictive model. Now decision tree regression. Decision tree is a supervised learning algorithm used for regression tasks. In this task, I have employed decision tree regression to predict the math score of student. The model is trained on the training set and evaluated on testing set using metrics such as mean squared and R squared. Mean squared measures the average square difference between the predicted and actual math score, while R square indicates proportion or variance in math score explained by the model. So here we can see the result. Mean square error is 60.86 and R square error is 0.74. So now comes the logistic regression. Logistic regression is another supervised learning algorithm primarily used for binary classification tasks. In this slide, I have applied logistic regression to predict the math score. Although it is designed for classification, we can still use it for regression by converting math score into discrete categories by rounding them. We evaluate the model using metrics such as mean squared and R squared, similar to the previous slide. Mean squared is 216.61 and R squared is 0.10. The next and the final algorithm I have used is random forest regression. Random forest regression is an assembled learning algorithm that combines multiple decision trees to make predictions. In this project task, we utilized random forest regression to predict the math score. The model is trained on training set and evaluated on testing using metrics such as mean square and R square as previous. Random forest regression delivers improved accuracy and compared to single decision tree, making it a powerful algorithm. So here we can see the mean square error is very much less in comparison to other models, and R square error is 0.2884. 0.84. Model comparison. The result from the three models are compared based on the mean square error and R square error. The random forest regression model performed the best, exhibiting the lowest MSC and the highest R squared score, indicating its superiority in predictive math score compared to other models. Conclusion: Predictive model process on the student performance dataset demonstrate the random forest regression model solve the highest predictive accuracy for the math score. However, the further analysis and refinement can be performed to improve the or explore additional features that may enhance the prediction task. Any questions and discussions? So I serve there as an opportunity for the audience to engage in questions and discussions. Thank you.
Okay, Shivanshu. Need to work on the delivery of the presentation a little bit. The presentation knowledge was itself really good. Uh, the things are explained well. But the delivery needs to be a little more confident on your side. It was, even though you knew most of the things, but the delivery, it came out like you were trying to remember some things, you were forgetting things. And other than that, short story regarding a project needs to be there. Uh,
Yes, sir.
and I don't think any other problem is there. If there is any other problem, that I'll find while reviewing your presentation again. I'll send it in your review itself. Okay.
Okay.
Thank you so
Thank you,
much,
sir.
Shivanshu. Kushagra, you can start your presentation.
Hello, sir. Am I visible?
Yes, you're visible.
Yes, sir. Let me share my screen first. So, can you see my screen?
Yes, the screen is also visible. Uh, right now, your exploratory data analysis screen is visible with the coding part. If you want to give a presentation, be on the presentation part.
Yes.
Okay. Yes.
So, is my presentation screen
Yes.
visible?
Yes. Now it's visible.
Okay, sir. Let me start the slideshow. Okay, so basically, good evening, everyone. So my project is understanding the descriptive and diagnostic and predictive and prescriptive modeling. So, and the task in this project I have obtained here is exploratory data analysis. So first, I'll be reviewing the contents here. So first, it will be task description. Then it will be literature review regarding the EDA. Then I will give you a demo, and then finally conclusion and questions. Okay. So the task description is basically I have to perform a basic EDA, data analysis. I have been given a data set, and I have to perform the basic and visual analysis there. So descriptive and summary, summary statistics I have also found there, and visualization is also there. And last in the task, I have also checked, the accuracy of the data on the machine learning models. So basically, our end goal is to use that data to get a predictive model out of that. So we have to check the accuracy here. Okay, finally, now let's start with the literature review here. So first, I would like to start about what our data was all about here. So the data set here basically it contains the transaction that was made out of credit card, using the European card holders. So it's available on Kaggle, and it is basically containing 30 columns, and it contains 284,000 rows. Basically, those represent the transactions that have been made in the 2 days for which the data set was recorded there. Then, the original data set that was recorded there was there contained a huge amount of columns there. So what they gave to us was the dimensionally reduced data set here. So the features that were available in that data set, V1 to V28 columns, so they are basically the PCA transform. PCA is a dimensionality reduction technique. So what PCA basically does is it checks the eigenvalues and eigenvectors of the uh, column. First, it standardizes the respective columns and check the eigenvalues there. and those eigenvalues are used to identify the most variance, the maximum amount of spread that is available in the data. So we what we do here is we do an orthogonal transformation on that most spreaded direction of the data, and we obtain these 28 columns from that PCA transform data. Then we also have the time feature here. The time feature represent the basically the time for the data, and then we also have the amount feature that basically represent the total amount. These columns are not at all affected by the PCA. Then there is class feature. So one is for fraud value and zero is for non-fraud value. One of the major peculiarity that you can notice in this data is that this data is imbalanced. What imbalance means is we have this data as a classification task. So we have only 492 fraud cases, while it has total of 284,000 transactions. So since we only have a little amount of fraud cases, we can't really judge the data on its fairness. It's basically skewed towards the non-fraud cases. So this is basically the imbalance that I was mentioning about. So this basically poses a challenge here for modeling and analysis purposes, basically because the fraud cases that we have to identify are underrepresented in the data. So this is there. Then what is exploratory data analysis? Now this is uh, exploratory data analysis is basically one of the most critical steps that we perform before feeding the data, or before getting something out of the data, before feeding the data into a pipeline or feeding the data into a machine learning model. So what exploratory data analysis does is it basically involves understanding the structure of the data, what data is made up of, and what are the basic patterns that are available in the data, without already applying the modeling or without doing anything. So by uncovering these insights, we get the basic representation of the hidden statistics that is available in the data. So this is basically the exploratory data analysis part. It also basically helps in identifying the potential issues there that are available in the data, like inconsistency, uh, null pointer that is available in the data, and we also have missing values, outliers are also there. The skewness and kurtosis can also be identified from the data. So so basically testing our statistical methods on the available data is exploratory data analysis. So it also helps us in making informed decision because we have the output, we have the basic statistics, we have the basic pattern recognition of that data. So we get a basic meaning and basic structure of the data. So this can help us in making more informed decision, like which models we should choose further, or what should be done after that. So then why is EDA important? So EDA is quite important before feeding the data to a machine learning model, deep learning model, or any other major task. Before we do, we perform EDA. It is not only limited to the numerical data that we have in this task. It is also quite important in non-structured data, unstructured data, like images and voice and sound data that is available. So it's quite important understanding the data. So EDA helps us to understand the structures that are available and the content of the data set. Then also there is data quality assessment. Like data quality is quite important to assess before we feed the data to an model. So since if we have a poor quality data, then we shouldn't expect anything good out of their model. Uh, Basically, data quality assessment includes finding what the data contains, whether it contains outliers more, whether it contains missing values more. And also data quality assessment can also be related to image quality assessment if we consider the image data set, because before we feed the images to a machine learning or deep learning model or any image processing task, understanding the quality is quite important, because if the image quality is poor, we are expected to get a bad result in any of the further tasks. Then there is uncovering the patterns and insights by exploring the data visually and statistically. EDA can help us to discover the hidden patterns, trends, and relationships that may not be obvious by seeing the data, but we can find out using these EDA techniques so that we can have a better result. Then feature selection and engineering. So basically, feature selection is quite important, as it assists in selecting the relevant features that are important to the model and discarding the unrelevant or data that has already been quite uh, inappropriate for our model. So we can discard those data and we can only consider the relevant features. Feature engineering is also important, as we can model our features according to the need of the further issues. Then there are assumptions and limitations that are available. EDA helps us to validate those assumptions about the data and understand the limitation of the data. Then there is findings. We can also communicate our findings using visualization techniques and other statistical techniques that are available. So we can provide a better effect, and we can provide a better strategy to the audience or the stakeholders that are present in this. Then we can have a better modeling process if we have a better insight to our data, which we have to feed to the model. Then this we can also reduce the costly mistakes. So basically, costly mistakes here include the modeling part. So we can it also includes the financial part also. Like if we have a better understanding of our data, we can have a better understanding of what next steps we should take. This can help us financially also, like in stock market prediction, or like if we are analyzing the financial data, like if we are analyzing the customer data, we can also analyze where the customers are getting better goods, or what the customers are searching for more. We can analyze those similar trends using the EDA, and we can have a better result for ourselves, so that we can have a better financial output. And this also costly mistakes also include the computational output here. If we have a poor data, we haven't performed exploratory data analysis, then we will be feeding that poor data to our model, which will give us a poor result. And then we will again go back to our data that then we will again perform some analysis, then we will again feed the data. So it will not only cost our time, it will also increase the computational complexity. If we consider data sets that are like in big data or other structures, uh, that usually cost quite a lot of load on computers and GPUs. So those models takes quite a lot of time. So we can't afford to every time check the model accuracy, then go back and again edit something in our data or perform some pre-processing, then again enter the data in the model. So this is this is what makes EDA quite important. Then these are the some of the EDA techniques that can be used here, but I haven't used the time series analysis. As you can see, basically you will notice why I haven't used the time series analysis. As in the previous slide I have mentioned, we can use feature selection and engineering. So using feature selection, I have found out that the time column that was available wasn't quite important to our class, wasn't important to our model at all. So time series analysis I have skipped. This is also can be considered like reducing costly mistakes, as I haven't spent any time in analyzing the time series models here. So this can be uh, an example in the data set. So then first summary statistics. Basically it calculates the present descriptive statistics here, like mean, medium, mode, and variance and standard deviations. Those are the basic statistical values. These basically measure the central tendency of the data. Then we have uh, range basically determines the minimum and maximum values. We can also find using the range we can get a basic idea what is happening in the data. Then there is skewness and kurtosis. Skewness and kurtosis basically determines the shape and distribution. Like if the data is bell shaped curve, we can using this skewness we can determine whether is it positively skewed, like it is more distributed towards the left hand side or more distributed towards the right hand side. So we can get a better idea of this data. Then there is count and percentages. Count basically we can get how many of the data points are available for each column. It also gives us a basic idea whether there are null pointers available in the columns or not. So that is also there. And then there are percentages. They also provide information. Basically, these are quite useful in categorical variables also. Our data set doesn't contain any categorical variables. So yes, and then this is an example for our data. This is the summary statistics that is provided. We have mean, median. Median is 50%. Then there we also have minimum and max that provides us the range for each column. Then we have percentiles. We also have the count for each of the columns here. So you can see. Then we have data visualization. Data visualization basically provides us the visual analysis for the data. We can have a better representation for our data, and we can also it also gives us a better presentation to provide to us stakeholders here. So uh, box plot basically helps us in identifying the outliers. So outliers are basically points that are out of the quartile ranges. So what are quartile ranges? Quartile ranges are the the basic range that we have provided around the median of the data, so that we can find out what points of data, what data points are basically quite out of the way from the basic distribution of the data. So if we are able to identify those data, we can use the box plot to visualize that, and we can take further action, like either we can remove those data points, or we can use interpolation techniques or mean, median to fill those data points. Then there are scatter plots. Basically they show a relationship in the form of scatter points between two variables. Then there are line plots, same as scatter plots, but it helps us in getting a better visualization if there are trends involved. uh, Trends and also patterns, we can like in logistic or linear regression we get a better you know then there are heat maps present. It basically heat maps gives us a better idea in presenting a matrix of values. If we find we have here like 28 columns, we can use correlation analysis. Then we'll have a matrix of 28 columns versus 28 columns, so that we can get a better visualization here. So heat maps are used there also. Then we also have missing data values. So actually in this data set we didn't have any missing data, but still if we use outlier detection and we remove the outliers, then we can have missing data. So that can lead this to we can use those missing data points. We can fill those missing data points using mean or median there. Then we can also remove the missing data points. It's a basic conception here. If a particular row has quite a few number of missing data points in the columns, so we can remove that particular row altogether. So that is also there. Then we can also use imputation techniques, like using interpolation or using estimates, like I have already mentioned, mean or median, to fill the values. Then we can also treat it as a separate category, the missing values. So so that we can identify another pattern there. Then it comes outlier detection. Outlier detections are basically calculated using the z-scores. We use the standardized values to identify the outliers. We define the percentiles. The percentile is the basic percentage of data that is present beyond amount of data that is present up to a particular point. So we can use those percentiles to determine the basic threshold so that we can determine the outliers. Then there are box plots we can use to visualize, as I have already mentioned in the previous slides. So we can also use vincerization. It's a technique where we replace these extreme values with a certain and percentile value. Like basically, in most of the cases, we use the median value so that we can mitigate the impact of the data, the data loss that will be happening there. Then there is data transformation. We can use various styles of data transformation like normalization. It's quite prevalent in many techniques, in deep learning techniques and machine learning techniques. They perform data transformation in the form of normalization, standardization also. So normalization basically and standardization. Normalization basically scales the data between a particular range. It in the most cases it is between 0 and 1, and in many cases we can also set a particular range. Basically, this can be used, and this is used the when we use distance metrics in the evaluation of the modeling. So it's quite effective. So standardization is also the same. Logarithmic transformation, we can use the log of the values. And then there's power transformation. We can use power functions to uh, address the nonlinear relationship between the data. So the importance of data transformation can be determined if basically we have two columns. One column is like we say we have the amount, and the other column is we can like uh, uh, imagine it to be a particular distance, a particular flight, or particular distance covered by the flight. So if the amount can be quite exponentially high when compared to distance, but the amount might not have that much of an importance in the classification task. But since the amount value is quite high, the data set, the model will be more skewed towards the amount. So here comes the part of the normalization and data transformation, so that it can transform the data and make it compact, so that we can have a better you know uh, participation of both the columns here. So here this is an example, so that we can know the importance of data transformation. Then we can have multivariate and bivariate analysis. We can check various variables with each other, like correlation analysis. Correlation basically checks the strength. It basically checks the proportionality that we have been studying here. So if we have a high correlation between two variables, then they both grow together. If one variable grows, then the other also grows in the same direction. If we have a negative correlation, then negative high correlation, then we if one variable grows, then the other variables grows in the opposite direction and as strongly as the first variable has grown. And if we have zero correlation, then basically they are independent, and the growth of them does not affect each other at all. We can also use scatter plots to compare the analysis between two variables. Pair plots are also available, as we have done. And conditional plots, basically to if we condition certain variables based on a third variable, so we can examine the relationship. uh, so there's that. Then dimensionality reduction. In our data set, we already have dimensionality reduced data, so we can use the dimensionality reduction part. Uh, Basically, I have mentioned two parts like PCA and TSNE. So visualize the PCA I have already explained. The TSNE, basically used to visualize high dimensional in lower dimension. It basically preserves the neighborhood relationship, while the PCA, what PCA does is it uses orthogonal transformation, so it does not preserve the relationship. Uh, it is more preferred towards the variance or the spread of the data. So there is that. Then we can also perform time series analysis, but as I have already mentioned, since the time variable is not an important feature, as we have performed the feature selection, so we have skipped this part, as time series analysis won't give us any fruitful endeavor. But we can perform time series analysis, like display the variables over the time, so that we can get over a particular pattern, or we can use autocorrelation, so that we can find a particular regression algorithm so that we can predict the whether the output can be dependent on a particular time or particular part. Then we can also find seasonality, and we can find the trends available in the time series part. Then here comes the demo. So is my sir notebook visible? Hello.
Yes, it is visible. You can explain.
Yes, sir. So basically, this is where I have imported the data set here. So as you can see, it's basically I have used pandas for the data set, and this is the basically first 5 rows of the data set. And I have used the describe function, which gives a basically basic summary statistics that was mentioned in the slides. Uh, okay, and as you can see here, each for each column we have got a basic summary statistics mentioning count, mean, median, and you can also see for the last column also the range, the minimum part, the maximum part, and for the amount also. So this is the summary statistics that I have got. This is the info. The info basically gives the non-null components of the and the data type of the each column. So as you can see, the amount of rows for each column is same that are not non-null. So we can infer from this information that from this function that there are no null values available in the data set. So our data set is free of the null values. For confirmation, I have also used this function is null function, and try to find out the number of null values that are available in each column. And as you can see, the result is 0 null values are available in each column. So this is the conclusion here. No null is available. And I've performed the count plot here. As you can see, the count plot here for the class 1, it's quite low. It's not at all visible. But for class 0, that is non-fraud transactions, they are more than 250,000. So this can be used to show the high disparity that is available. I've also printed the values here. As you can see, 492 fraud classes are only available. So it was also mentioned in the data slide there. Then we have used to perform the density analysis for each of the columns. As you can see, each of the columns here, like V1 to V8 columns that I have performed the density analysis here. These are the PCA transformed columns. So PCA transformed columns are basically standardized. So you can see they are basically distributed around the value 0, as they are orthogonally transformed there. So as you can see, they are transformed, but the amount of spread for each column, the variance that you can see is quite uh, different for each of the columns. It is also affected by the outliers here. So as you can see, we have different density here, and but each of these are bell shaped curves with varying skewness here. So this is this, and we also have a time distant disk plot for time using measuring the density here, but we can't really get anything out of it, as it's quite bivariate data. So then we also have for amount, but amount is not highly spread here. As you can see, for the it has outliers, but it's not that much spread out. So the variance here is quite low. Then we have the correlation analysis. Now, one of the most important aspect here is that most of the variables V1 to V28 are uncorrelated in nature. As you can see, the low density of correlation present. The high density is basically the red one that displays the high density. They are basically representing that this feature is correlated with themselves because they are present in the diagonal of the matrix. As they represent column into column matrix. So those diagonal elements does not matter much, as data set the data column will be correlated to themselves also, but the rest of the data points, as you can see, they are uncorrelated. So, or the correlation density is quite low. So as you can see here, the rest of the data points are uncorrelated or low correlation density. So we can, conclude that since each of the variables are, uncorrelated, we can try to feed those features. Uh, we don't need to, perform any feature engineering here. So this can be said here. Then I have performed a basic train test split here. So train test split can be, splitting the test size into 25% and train size into 75%. Since we have a large amount of data set, I have increased, the from the usual that we use 80-20%. Then we have feature importance here. I have used the random forest to train the model and got the feature importance metrics here, so that we can, figure out what are the important features that are there for the random forest model. And as you can see, these are the important features that represent the feature importance for the model. But the amount and various other rows that are present here, including time, as I've mentioned, since time is not an important feature at all, so there is no point in performing time series analysis here. So that is that. Then we performed a basic logistic regression here, got a pretty low accuracy, 71% F1 score. Since we are, getting a precision recall and uh, accuracy, but we don't usually, prefer this precision recall and accuracy, since the class is highly imbalanced. So if even if our data set, supports, or even if our data set predicts all the, majority classes in the output, then also we will get a pretty high accuracy, as majority classes, exceed 97% or 99%. So even then we are getting a 99% accuracy, so there is no point in our modeling. So that is why instead of accuracy we are using F1 score, that, is a harmonic mean of the precision and recall, so that we can get a, pretty accurate analysis of the uh, classes that are, true positive and true negative. Okay, then I have performed random forest classifier also, but random forest gave us a pretty high accuracy here, almost 86%, and XG boost also 86%. So one can say that XG boost and random forest, they are bagging or boosting algorithms. So bagging and boosting algorithms, what they use are, they use different models. They are basically in the category of ensemble. So ensemble use different models together, and using those different models, we can, you know have we can, make the model quite robust to the outliers also. So the model is robust to the outlier when compared to, simple models like logistic regression. And we also tackle the difficulty that we face while, handling the imbalanced data set. So that is why I have preferred random forest and XGBoost. Basically they are ensemble methods, and each one occupies a bagging and boosting algorithms, and they boosting algorithms also, we, perform a chain, we form a sequential modeling. So this also helps us in, tackling this imbalanced data set problem. Then we have performed oversampling, as mentioned before. Oversampling means, using the minority class, we performed smooth. Smooth basically uses the minority class, interpolates between the minority class, and increases the number of samples there. But using smooth, we also have included, uh, basically we also increase the uh, amount of, the bias that was there towards the fraud classes. Since the bias was increased, you can see that the F1 score decreased by a lot, and the random forest classifier also, its accuracy decreased by 5%. So in this case, in this data set, using the oversampling techniques, or using the smooth techniques to improve, increase the amount of minority samples, is not beneficial at all. And same happened for XGBoost also. And we also performed undersampling, but then undersampling, was quite, not at all beneficial. So we quite let me rerun, I guess. it wasn't. So after performing the undersampling technique, we were remained with only 400 samples, 370 samples. So as you can see, 370 samples will not at all give us, any beneficial uh, accuracy at all. I have also run this model also. As you can see, the F1 score we have got around 10%. It's less than logistic regression all. So this is that, and then we also have outlier detection. So outlier detection, here we can see that we have created box plots here. So I guess it got, as you can see, we are getting the box plots for various columns, and there are quite a lot of outliers present in each of the PCA transform columns. So this time basically does not contain any outliers, but here these columns contains the outliers. But since we are using random forest and XGBoost that are not at all prone to outliers, they can use boosting and bagging algorithms. So outlier detection basically is not that much beneficial in our case. So yes, as you can see, we have got outliers for various other columns, and there are quite a high number of outliers present, as you can see here. This also gave us statistics for each of the column, the number of outliers present. And since these NaN values that are present, that represent that these outliers are considered as null right now. So then we can use many of the outlier techniques that we have mentioned. But then again, since we are getting the maximum accuracy even after oversampling and undersampling techniques, we are getting a maximum accuracy of 85%. So we are pretty sure that outlier detection isn't gonna help that much. Then coming back to the presentation, then coming to the conclusion here, we performed EDA on the given data set, basic EDA, as I mentioned, summary statistics, and measure the central tendency since there are large number of columns there. And we also performed, correlation analysis, but found out that these correlation values are not at all high, and they are uncorrelated features. So we can't perform, a better feature engineering. So they are independent features there. Uh, Basically, the reason for that is also, the PCA dimensionally reduced columns that are present, since they are dimensionally reduced and orthogonal projection of eigenvalues that are independent. So the features are also uncorrelated there. Then we also found that the undersampling leads to a drastic decrease in model accuracy. As I've shown, the random forest also gives us only 10%. So it's quite a low accuracy. So undersampling can be rejected at, and then we also, you know, got to know that the imbalance data that works better with ensemble techniques rather than the logistic regression or SPM that are simple classification techniques. So this is the conclusion that I have come after performing the EDA. Then any questions? These are the references: the Kaggle data site and a simple towards data science website. We have studied basic techniques, and subsampling I have studied from the statistics also. Thank you. This is the email.
Kushagra, this is one of the very good presentations that I've heard. It's just that it was a little too lengthy in the sense most of the content that could have been spoken by you, it was on the slides itself. So you explained the whole process of making the data analysis, what was the use, what type of different modules and sets you used for the data. But you also gave the examples for some of the things that you didn't include. So you mentioned that also. So I wanted you to keep the key points. Okay. So there are one-liners to explain those key points in your slides, correct? So what I want you to do is keep those key points, but take the one-liners away, these statements, and you explain those key points yourself and try to only explain the key points which you have used instead of giving all the key points in the given data set. Okay. Other than that, the whole demo part was very interesting because you have done all the variations that were required for the data, and I don't think I've found any problem in your presentation at all. It's just that there's a short story missing, like
Uh,
you could have included. Okay, I want you to include a short story stating the relevance of your project in the
yes,
day-to-day life.
I have mentioned it in this slide. Why is EDA important? Uh,
So
Importance of exploratory data analysis here.
why is EDA important is still not a story explaining the relevance of the project in their real life. It is you are explaining the whole project itself, why it is important, and but okay, I'll still consider it. It's fine. But and at the same time, try to when you were explaining about the charts, that line charts and all those things,
Yes, sir.
you try to include diagrams of those charts while explaining alongside. Okay.
Okay, sir.
That is one of the gripes that I had. Other than that, I don't think there was any problem. If I find any while reviewing your presentation, okay, while scoring,
Yes, sir.
I'll send it to you in your review. Okay. Thank you, Kushagra.
Thank you, sir.